Okay, we're going to begin equations with radicals. I know this is radical equations, sounds kind of exciting, but it's just equations that involve a square root or cube root potentially. I think mostly we'll give you square roots. So let's take a look at this. We want to attempt to isolate the radical on one side, then you square both sides. If it's a cube, you're going to cube both sides. If it was a fourth root, you would take both sides to the fourth power and then solve for the unknown. Make sure that it makes sense. This is one that you got to make sure that you definitely check your solutions. So first thing we're going to do is subtract 2 from both sides. We end up with x minus 5 on one side. The other side, we've now isolated our square root. Then what we want to do is we want to square both sides of our equation. Okay, now that's going to eliminate this square root. We get 4x plus 1 equals, if I square this, we're going to go ahead and multiply this out, x squared minus 10x plus 25. Okay, it's a common error place right there. Some of you might think, well, wait a second, when I take the square root, I square something that's square root, shouldn't I use absolute value? And the answer is yes, but we're not going to go down that road here. We can actually take care of that when we check our solutions. If we just check our solutions to see if they make sense, it'll take care of the whole absolute value thing. But anytime you have a quadratic, you got to bring all of your terms over to one side. So I'm going to subtract a 4x and subtract a 1. I get x squared minus 14x plus 24, and that's what we're left with on by squaring that. Okay, now we just have a quadratic here that we need to take a look at, which luckily for us, if you think about it, it's actually factors. What two numbers multiply to give you 24 and add to give you negative 14? Maybe you don't think of it right off the bat, but that's actually 12 and negative 2, or negative 12 and negative 2. So we set each factor equal to 0, and we end up with x equals 12 and x equals 2. Now, in this case, like I said, before we circle these as our final answers, we want to check that. Oops. We need to check it quickly. And that can be accomplished just by putting it back into the original equation. So if I get 4 times 12 plus 1 plus 2, does that equal 12 minus 3? That's the question here. Are those things equal? Well, we get the square root of 49, which is 7, plus 2. Does that equal 9? Yeah, it does. Okay, so we end up with 9 equals 9, right? Which is definitely allowed. So 12 is definitely one of our final answers. Then if we're checking our other answer when x equals 2, if I do the square root of 4 times 2 plus 1 plus 2, does that equal 2 minus 3? You're going to see here that this equals 3 plus 2, and this equals negative 1. And so we get 5 equals negative 1, which does not make sense. Okay, so x cannot equal negative 2. So our final answer for this problem is just x equals 12, and that is our only solution.